Good morning, students. Happy snow day. Actually, it finally stopped snowing right now. I wanted to just go over the solutions of this worksheet that was from yesterday, the gizmo, since we did not have school today. It's totally optional if you want to check your work, but I will go step by step through all the solutions to make sure that you're getting the practice that you need. All right, so for the first thing I like to do for these problems is I like to identify how many electrons these elements have. So for sodium, we know that sodium has 11 electrons that we need to account for. I need to actually get a real periodic table. And we can use either this flow chart or we can use this periodic table to help us figure out what electrons we need to fill. Starting off with 1s, there's 2, 2s, 2. That counts for 4 electrons. Then we go to 2p6, and then 3s. Well, for strontium, strontium has 38 electrons. So we'll have to keep filling up. It might not fit very well. So 1s2, 2s2, 2p6, 3s2, 3p6. Now we're at this point. 3p6 is argon. So we need to keep counting. 4s2, then we fill up the 3d. 10, now we're up to gallium. 4p6, we finally made it to krypton. And then 5s2, that gives us the strontium. So we filled in our electrons as we see them occupy in this image. For boron, this will be easier if boron has 5 electrons. If we look at our cool periodic table, we can actually already see that all we need to do is fill up to 2p1. So 5 electrons, 2s2, 5 electrons, 1s2, 2s2, 2p1, that matches. Silver, it has how many electrons? It has 47. So 47 electrons. At this point, I think I'm just going to copy all the way up from here. Nope, we're not copying. We're going to write it all down. So from filling in, we'll do 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Now at this point, I should have gotten up to zinc because that's where the D block is. 4p6. We get all the way to krypton. 4p5s2. That's strontium, where we were just at. 4d10. That's too many electrons. We need 4d. 1, 2, 3, 4, 5, 6, 7, 8, 9. 4d9. Titanium has how many electrons? Titanium has 22. And we know that titanium's in the D block. Specifically, titanium is in the 3D block, and it is the 1, 2 second element in the D block, so it should end up in 3D2. So we'll fill in as required. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. That gets us up to here. And then we'll do 3d. How many electrons? 3d2. This should add up to 22. 2, 4, 10, 12, 18, 20, 22. Perfect. Fluorine. We should know is in T2p6. It's in period 2. It has 9 electrons. So we'll start off counting per usual, 1s2, 2s2, 2p6. Oh, I think we overpassed it. That's 10 electrons. We need 9. So 2p5, 1, 2, 3, 4, 5. And then we see that fluorine would be up here, 2p5. So this is how we check our work to make sure we're counting electrons as we need to. For 7 through 11, we all are working backwards. So we are actually trying to identify how many electrons there are. And notice that this must be a neutral atom, which means the number of protons must equal the number of electrons. So counting, 2 plus 2 is 4, 10, 12, 18, 20, 30, 34. 34 electrons is an element, selenium. Well, we know at this point that instead of counting, that all the way up to here through P6 should be argon. That's 18. So 18 plus 2 plus 5 is 25. An element that has 25 electrons is manganese. Oh, manganese. Using that same principle, all the way up to here is 18. All the way up to here to 4p6. 4p6 will be krypton. Krypton has 36 electrons plus 5s1. That's 37. Hi. 37. Uh, 37 is rubidium. We also could have just identified rubidium by being 5s, which means it's in 1, 2, 3, 4, fifth energy level in the s block for S1. Here we can also use the same principle. 5p3, where we know that this is p2, p3, p4, p5. 5p3 will be 5p1, 5p2, 5p3. It's antimony Sb. And we can actually check here, 5p1, 5p2, 5p3. Antimony would be the appropriate element. 3p1 similarly, we know this is 2p, this is 3p. 3p1 must be aluminum. So there are multiple ways you can answer this question. Work harder, not smarter. Work smarter, not harder. All right, now we're going to do the electron configuration for the following elements. So we're going to identify that iron has 26 electrons we need to account for. That double gas previous to that is argon. So we're going to write argon in the electron configuration. After argon, we are in period 4. This should be 4s, 2. This is 3d, 3d1, 3d2, 3d3, 3d4, 3d5, 3d6. Barium has 56 electrons. The noble gas before barium should be barium, xenon. Xenon, after xenon, we're in 6s, 6s1, 6s2. 6s2. Iodine has, and we can double check our work by knowing that xenon has 54. 54 plus 2 electrons gives us 56, which is barium. Iodine has krypton. After krypton, we're going to be at our 5s orbital, so 5s2. Then we're going to go to 4d10. Now that's 12 electrons. If krypton has 36, 36 plus 12 is 48 electrons, and we need to get up to 53. So iodine should be 4p5, because 48 plus 5 is equal to 53. Arsenic is 33, similar enough. closest noble gas will be krypton. 5s2 will be filled, and then 4d10 will be filled. Arsenic is 1, 2, 3, so we'll be at 4p6. I mean 4p3. Now do the noble gas for the following elements. Cesium. Cesium is here. Cesium is noble gas is xenon, xenon. And then we're going to do 6s, 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 1 electron. Sodium, the nearest noble gas is neon. Neon is 10. Neon plus 1 is, this is period 3, so it'll be 3s1. Tin is 50. The nearest noble gas to tin is krypton. Krypton, at this point, we should know that krypton will let us start at, it's period 4, so we'll start at period 5. We're going to start at 5s. 2, 4d10, and then tin would be 1, 2, 4p2. Lastly, radium. Radium's clearest noble gas is radon. So Ra, which is 86 electrons. We're in period 7, so this must be 7s2, because there are two electrons, so it's 56 plus 2 is equal to 58. And that's, nope, 86. 86 electrons. So this is 86 electrons. This is 2, then that's 88 electrons, which are held accountable with 88. Now for the shorthand and longhand, I'm only going to do the shorthand for these. So for well, actually, let's just do, they're not that bad. So for nitrogen, nitrogen has 7 electrons. By filling, we should be able to do 1s2, 2s2, 2p. We need to have 3 to add up to 7. Now we're going to do Aufbau's principle. 1s is filled first, then it's 2s. Now for the 2p's, it's going to go 1, 2, 3. This will be 7 arrows total, and making sure that's single before double. Chlorine, chlorine will be similar, 1s2, 2s2, 2p6. The nearest noble gas to chlorine is neon, which is 2p6. And then we'll go to 3s, 3s2, and then 1, 2, 3, 4, 5, 3p5. Filling in the arrows, 1, 2 is done. Energy level is done. Higher energy level. Single, single, single before double. Double, double, double. This is complete. Now we can add to 3s. And then now we are still in 3s, so we can double up. And now single, 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 double, double, and then this one should be unpaired. This 12 electrons, the nearest noble gas is neon. At this point, we know that 1s2, 2s2, 2p6 is neon. Then we go to period 3, that'll be 3s2. We'll do lower energy level, then increase in energy level. In the same orbital, we'll have to do single, single, single before double, double, double. Then single, double, that accounts for 12 electrons. Neon, up at this point, if you guys, 2s2, 2p6, we know this. Single, 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 double, single, double, single, 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 double, 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 2, 4, 6, 8, 10, that's 10 electrons. Phosphorus, our nearest noble gas is neon, so we just copy. 2p6, 1, 2, 1, 2, 1, single, 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 double, double, double. And we need to count for 5 electrons after neon. So we go to 3s2, 1, 2, And then we do 1, 2, 3 for phosphorus. 1, 2, 3 for phosphorus. Determine which of the electron configurations are not valid. All right, let's look carefully. I haven't done this personally. All right, so let's see if first the energy levels are being ordered accurately. So for 25, let's check the order. If you're doing 1s2, that's correct. 2s2, that's correct. 2p6, correct. 3s2, 3p6, 4s2. Oh, and then we notice that this skips to 4d10, but we know that it should actually be 3d10 and then 4p6. So this is incorrect because it skips Aufbau, which means that we do lower 3d, then we do 4p. We'll do a similar process for question 26. So let's see. 1s2, 2s2, 2p6, 3s2. And then here we go to 3d5 instead of 3p. So this is wrong because of also it skips it. It needs to be 3s and then to 3p, not otherwise. Radon is here and it's in the 6p land. So let's just jump to 6p. 6p, then will be 7s. That's correct. After 7s, we go to 5f. This is wrong, so 7s goes to 5. Oh, wait, that is correct. 5f, 7s, 5f. So this is correct. Sorry, I misread that. So this is correct because 7s then goes to 5f. All right, krypton. Krypton is 1, 2, 3, 4p. So we should be picking up from 4p, 4p, then it goes 5s, that's correct. 3d10, Mr. Kirby didn't capitalize this. 4, 5s, 4d10, that's correct. 5p5, and that is accurate. And we notice that there's nothing unusual because 2 is the maximum, 10 is the maximum, and 5 is halfway filled, but that's okay because it's the last energy filled. So this is correct. Xenon is incorrect because this is not an electron configuration. If you wanted to do it for xenon, you'd have to start off with krypton, and then krypton would be 6s, 2, 5d10, 6p6. It's incorrect. Xenon, we follow the filling rule. 6s2, 4f14, 5d10, 6p2. This is possible because it follows Aufbau. Great.